Uh, Hello, everyone. Today, I'll be discussing on the health center facility, which I will be operating on the Mars habitat. So, first, we'd like to see some of the main hazards of the space flight as well as the space exposure. So, as you can see here, that out of the blue marble or our mother planet, there are altered gravity fields that will lead to balance disorder like fluid shifts and cardiovascular disorders, as well as bone loss or muscular atrophy. So apart from that, there is another candidate is space radiation that is actually inducing cancer and other cardiovascular diseases, as well as central nervous system disorders. So another aspect of the crew were experiencing is the isolation of the confinement in the extreme habitats. So there will be some behavioral impacts or sleep disorders, or maybe there is a alteration in team dynamics. So another aspect of hazard that may be distance from the earth, that is as they are in huge distance from earth, that requires autonomous medical care, and also you cannot send command very fast from the earth base. As I know that sending command is requiring 45 minutes to reach to Mars. So apart from it, there is also the hostile environments. Therefore, the toxic regoliths is there in Mars, and the CO2 levels or the scarcity of water and food, that also can cause mental and health issues with the crews. So next, I'd like to elucidate on the space radiation that can cause harms to the human bodies. And as you can see that DNA damage as well as the reactive oxygen species and the several epigenetic changes, that means the changes that are induced in the DNA, they can cause genomic instability, aneuploidy, as well as tumor promotion in case of the affected astronauts. So, and with this amount of knowledge, we would like to then look upon some 50 medical emergencies that can be happen during long-term space missions. That means here, as you can see in the red marked area, that is the hypervolume shock, as well as the toxic exposure, as well as the head injury. And here also the yellow areas as well as the green areas. So what they suggest, they actually, this y-axis is actually suggesting the likelihood of the negative impact of the mission success. That means the mission will fail by these aspects. And this is the impact of non-technical skills. So as you can see that like minor skin laceration or small fracture won't cause the abortion of the mission, while severe head injury or toxic exposure to radiations can cause aborting the mission. So we will need to build such a habitat that will protect astronauts or the crew members from the radiation and other exposures. So next, I will be presenting a prototype of Martian biomanufacturing, and here is its artistic impression of the design. And as you can see that here is the solar panels, and it is the dome-shaped habitat that is situated in the red planet. So how we will accomplish this? So towards that, I would like to show you some of the steps as suggested by the foster partners, which are one component organization of NASA. So what they suggest, they actually suggesting sending robots first into the red planet. And here you can see that robots have arrived in the red planet, and they are now starting to set up the base camp here. Next, they will build up the Mars habitat, and as you can see, it is the final Mars habitat that is looking awesome actually. So Next, I will show you some videos so as to show how this can be accomplished. So and this will help you understand to better accomplish the mission or the habitat. So just wait a minute. Yeah. So this mission will employ the 3D printing, which is a revolutionary strategy of modern day science. And as you can see that this is the space capsule that is going towards Mars. And it is the initial deployment, and it's now entering the atmosphere, and this is the landing or the touchdown by the robots, and they are now building up the habitats, and now the rockets arrived, and these robots will now build up the solar panel or other things. Yeah, they are like a bunch of ants playing together. And here comes the total habitat that has been accomplished. And now the asteroid will arrive and accomplish their mission. So next, I would like to give you some overview of the health center that will be situated in the Martian soil. So this facility will be intended to take care of the routine health checkup of the crew's personal health, and this will employ the personal checkup as well as the artificial intelligence-based monitoring. Next, in such long-term mission, what we need to take care of the psychological health or the physical well-being of the crew. So as to accomplish that, we'll take care of individual, interpersonal, as well as organizational issues that will be involved in living in such a system. So next, any medical emergencies of the mission, and also in this new normal of COVID-19, we will also take care of the infectious diseases that can quickly spread and complicate the management of emergencies, even in a young and fit population. Next, we will develop potential medications and the therapeutics to employ the in situ manufacturing from the Mars regolith and the ice crust, and also will employ the artificial intelligence-based database to develop such drugs. So next, it is the internal design of my facility. As you can see here, this is the living area, and there are dedicated spaces for kitchen, dining room, gyms, and individual bedrooms. And here, now you just look into the bottom of the dome. As you can see that in the middle of that, there will be facilities to maintain medical emergencies, surgery, as well as patient care. And there will be a research area where new drug development can be done by AI-based technology. And also there will be a specified area for routine medical checkup, as well as the psychological examination of all the crews. And next, in my specific habitat, there will be infrastructure for differential imaging techniques for the diagnosis of differential disease conditions like MRI, CT scan, and this will be done by AI powered machines as well as the robots. Next, I will have the facility for in situ manufacturing, food and pharmaceutical synthesis, as well as aquaponic system, as well as a vertical garden as suggested by Dr. Julio. So next, these are some of the technologies that will be necessary for the operation of installation. And as you can see that here, these are the artificial intelligence based robots. Like I have collected these images from the images of Interstellar movie. These are the robots called TARS or KISS. So these robots may help the healthcare professionals to better understand the disease conditions, as well as to improve the quality of life of the astronauts. So, and as you can see here, this is Sunita Williams, who is actually doing exercise in the International Space Station. So next, I would like to propose some in situ modeling or in situ resource utilization that are there in the Mars, like ice, atmosphere, regolith, as well as the sunlight. As you can see, these are the polar ice deposits, and there are the hydrated minerals like perchlorates, etc., and SiO2, maybe Fe2O3. So from these, we will take all of them and will develop in situ resource utilization in this facility, and that will be further bifurcated into ISM. That means the in situ manufacturing of several materials like medicines, foods, materials, as well as the biofuels. And there comes the most important part, that is the FPS, that food and pharmaceutical synthesis facility of my in situ modeling. So these will help to provide the crew members a sufficient amount of fuel, medicine, food, as well as materials. So this is my organizational structure, and I will employ a multi-specialized physician, another general practitioner, paramedicos, nurses, psychiatrists, as well as biomedical engineers and chemical engineers. And the multi-specialized physician, he will perform surgeries, provides dental care, and he will develop several healthy nutrition plans and keep up the crews with basic health data that will be assessed by the artificial intelligence. And the general practitioner, he will provide patient care apart from the routine checkups, and he will assist the multi-specialized physician in surgeries. And there comes paramedicos and the and the physiotherapists. They will go for rescuing the crews who are in emergency and trains the station's crew in first aid procedures. And then there comes nurses. They will perform basic clinical examinations, and they will also assist physicians. And next, there will be a psychiatrist. He or she will assist the implementation of the mental care procedures of the astronauts. And next, that is one of the important crew of my habitat, the biomedical engineer. He will work in biomedical research and towards developing drug development by the in situ management. And the chemical engineer, that will he will take some Mars regolith or the polar ice cap water, as well as CO2 to provide constant supply of foods, pharmaceuticals, and fuels to the astronauts. And finally, there not less but the least, there comes artificial intelligence powered database, as well as machines and the robots that will assist the human subjects to achieve this entire goal of health facility. Next, I would like to show you the architectural view of the medical system. And here you can see the ground system that will be operated from Earth, and here the flight systems, or maybe the habitat systems. So there are several modules here, like medical modules. They will supply medical supplies, medical devices, and crew health and performance data system will monitor the crew health, and they will store every data of the health of the crew, or regarding the health, regarding another propositions. They will store everything in the database. And there comes health and wellness mission task performance support system, and also the natural and induced environmental protection. As we know that there is a severe dust storm that are very frequent in the Mars. So this facility is also there. So we'll treat crew as caregiver as well as patient, depending on the situations they face, and they will coordinate with other facilities like greenhouse and the main station to work in a coordinated way. So next, in the astronaut training program, I would like to introduce one of the revolutionary innovations by the European space agencies, that is the hibernation strategy, that is the torpor strategy. So what they actually tells that they will go to, or they will employ mechanisms to reduce metabolism, as well as this will slow down the heart rate as well as the stress of the crew members, and this will lead to reduce the payload with respect to the oxygen, food and water. But this will require the monitoring of artificial intelligence, and thus this mission can be accomplished. So I will now show you some of the conjunction of biology and engineering. So here the biology aspect of this is that it will cope the challenges in adverse environments of Mars by reducing the metabolism, which is a very key mechanism in mammals existing in the Earth. So the engineering part, it will embed and enable torpor technology in space missions with some suitable space mission architectures by qualified professionals. And with all this will establish torpor that can be used to mitigate the physiological as well as the behavioral stresses of the crews. So here is also some of the assumptions. Here you can see these are for 6 crews, and for phase 1, this will be the preparatory time for torpor and energy requirements. Therefore, the metabolism is reduced, and during the torpor, in the reduced metabolism environment, they will not take any foods, but only consumable is oxygen, and only waste product is the carbon dioxide. So here you can see that in the phase 3, after the torpor, the nominal recovery period is about 20 weeks, and as a result, no memory loss or skill decay was assumed. So these are now in hypothetical modeling, but I'm sure this will accomplish successful space missions in the future. Next, these are some of the YouTube videos to train my astronauts in my facility. Next, here comes resources for that will be utilized for 1 week. So as my crew capacity is 7, the food for each astronaut consumes about 2.7 to 3 kilocalorie per day. So as a result, for 7 days, individual intake will be 18.9 to 21 kilocalorie, and amount of food that will be required for 1 week is the amount of food that will generate 132.3 to 147 kilocalorie of energy. And next comes water. Considering 3 liters per day per person of water consumption, we'll assume that the water requirement will be about 147 liters. So next, these are the guidelines that I want to provide some of the other facilities, that you must sanitize your UVA suits and boots while visiting the habitat. Otherwise, as we know that there are several toxic minerals in the Mars regolith, so that can cause problems in air filtering, as well as that can damage other related medical appliances. And also take care of your gadgets that we have provided you for your health monitoring, like the space blanket and other things. So in case of any of the difficulties, you should report to the health facility as soon as possible through your user interface. As we know that in such difficult times of COVID-19, the personal interaction may not be permitted. So next, these are some specific protocols or routines that I will be maintaining in my facility, like routine checkups, psychological consultations, and also the radiological analysis that is very important in the from the perspective of the space radiation, and constant cleaning of the entire infrastructure. And hence will validate the medicines that we are generating in the in situ conditions and prepare a daily report. So here are some protocols for safety. The medical equipments need to be sterilized, and will use masks, disposable gloves, syringes, and PPEs. And also you will use the biosafety cabinets, anti-radiation safety cabinets.
We are returning the record.
Okay.
We had a technical problem related to dust storm on Mars, but you can continue, Saha. Good luck.
Okay. Okay. There are several protocols regarding the safety of the crew members of my facility, like routine checkups, as well as the physiological consultation or the mental care, and the radiological analysis that is very important in the perspective of the space reservation in the Mars. And also will employ constant cleaning of the entire infrastructure, and will validate several medicines or the pharmaceuticals that will be used, and will prepare a daily report on the basis of that. So, next, here is some protocols of safety in my habitat. So we'll sterilize the medical equipment and use masks, disposable gloves, syringes, as well as PPEs, and will use the biosafety cabinets as well as anti-radiation safety cabins. That is very important with respect to the Mars conditions. And last but not the least, appropriate sterilization of the medical devices. That will be very important to maintain the well-being of the crew members. So here are the some protocols of safety that are given by the World Health Organization. And as you can see that there are several things like before anesthesia, that has the patient confirm the identity, that means the consent. Then during anesthesia, does the patient have any allergic reactions? And before skin incisions, there are several guidelines are there. And after the patient leaves the operating room, the sanitization or maybe the sterilization of the devices, sample labeling, that are very necessary for maintaining the healthy conditions of both the crew members as well as the healthcare professionals. Next, we'll employ some of the measures for the occupancy of my crew members, like to organize the video meetings of the crew members with their family, and maybe we can provide some music or some Netflix to watch for, and something like the other things. So that their mental health or the physical well-being can be maintained. So next, here is my vision for food micro production. There is a aquaponic system, as you can see, that that is labeled as 1. This is the fish culture tank, and after fish culturing, the waste products are scavenged by the bacterial system that is there, that is here. And the scavenged products that will subsequently broke down to the nutrients, and this will be provided to some of the aquatic plants or maybe algae to grow successful ecosystem. And therefore we can achieve foods, maybe from the aquaponic system we can have some medicinal plants as well as for something for foods also. So next, coming to the 3D printing, this is a revolutionary approach, and as you can see that these are the three of the main 3D printing objectives that are employing in the art conditions. This is the inkjet bioprinting. They are actually employing thermal and piezoelectric effects, and then there comes the orifice free bioprinting. Here you can see that they are actually done by lasers, and this laser induced forward transfer, that means the lift that will absorb the cells and they will eventually grow into some of the tissue sections. And there is also the intrusion bioprinting that will be operated by the mechanical presses. And as you can see that by 3D bioprinting, you can generate prototypes of the 3D printed kidney, or maybe 3D printed cartilages or bones that will be again useful for the mass condition as well as from the art scenario. And here are some of the spin-off technologies that we can apply in the art conditions. That recently a cancer detection device has been discovered by the crews of the ISS as well as NASA, and they can detect cancer by employing hardwares as well as by employing the flow cytometric analysis. There comes the astronaut artificial intelligence system that can be used for monitoring patients at home. And as we know that when astronauts go out for the habitat or maybe in the for spacewalk, their spacesuits contain numerous sensors that can monitor the body temperature, maybe heart rate, how much they are sweating. So these informations are immediately communicated to the health facilities out there. And as we can see that we can use similar kind of systems in the patient care system or patient support system there in the art, so as to monitor patients in a better way remotely. That is most important. And here are the other medical related spin-offs like the laser angioplasty, digital cardiac imaging system, digital imaging breast biopsy system, artificial heart system, and there are many of that can be found in this document. So next, I would like to propose some of the guidelines that can be applied in the day-to-day life on the Earth. So guidelines for social isolation, and that is very important in the context of the COVID-19 and the pandemic, and guidelines on the exercises, guidelines on nutrition, as well as guidelines to operate a healthcare facility where the resources is very limited. That means in the remote areas, we can operate a health station like the Mars. Next, here are some of the sustainable development goals. That means we'll use the optimum resources, and this can also promote the health and well-being, as well as the gender equality amongst the different races and the nationalities across the world. And this will also promote partnership and international collaborations. So here is my contact info, and hope you have enjoyed the presentation, and I'm now open for the questions.